Good morning, SQL Bits fans. Last day of SQL Bits, huh? That's crazy. It's crazy that this is the end of the week. Hey, do me a favor. If you're online, maybe there's a way for you to do this through a chat. If you're here in person, somehow to do this, please walk up to somebody in these orange shirts today and tell them thank you. This is a community-run event. Can you believe this is one of the coolest events I attend in the world each year, run by the actual community, so please give them a big thank you. It's an incredible event. So I was in the speaker room for this session. Some person there says, Bob, I saw you have a session called Hidden Gems. Is Microsoft hiding something? I said, yes, but not on purpose. So you've seen me present SQL Server 2022. I did this yesterday, Wheel of Power. I've got some huge major features, intelligent query processing, all this really cool stuff. As I was thinking about SQL Bits, especially Saturday session, right, free day, what could I present that doesn't quite make the headlines? Little tiny nuggets of things that actually are pretty cool, but really don't sometimes allow me to get in a big session on SQL 2022. So this is what this session's about. It's things that are hidden that I found from developers, in extended events, in our code, from talking to other people. Oh yeah, sorry, you didn't know about that? That's in the code. I'm like, oh my gosh, somebody's gonna love this. So that's what we're gonna do today. We're gonna do some stuff, we're gonna show you some demonstrations. You're gonna wanna know how to get this stuff now. Right there, those sites. The deck's there, the demos are up there. In fact, if you go download the deck, the demo recordings are in the deck. So you can go back and just play the recordings, and if you unmute the slides, you can hear me behind the scenes in my house in Texas talking, oh, by the way, this is how this kind of thing works. So you have everything you need. Logistically, though, you might have a few questions. We have some great moderators here up front, online, here in the audience. We're gonna use the online web app to do this. I'll take some fixed points in the session itself, stop and say, hey, I've got a little monitor over here. Do we have any questions? If you're here in person, right after this, I'm gonna be ushered off the stage to go sign books. So I'm at the booth today for another hour after this, signing some books. I'll be at the booth as well, probably during lunchtime. Please come up and ask me a question if you want to ask it in person if you're at the event. Okay, real quick here, by the way, I thought it'd be fun, a little research. What is a famous hidden gem? If you don't recognize this is the Hope Diamond, which is today housed apparently in the United States Smithsonian Museums and appeared as a fictional diamond in the movie Titanic. So it's a hidden gem. And so are these. Some new extended events, some things about availability, scalability, something pretty cool called Purvey's List, and a little bit at the very end talking about how to archive with data lakes. Let's go rock, let's do it. Look at this stuff. Nobody knew about this. I didn't even know about this. We're gonna show you what an anti-pattern looks like, a query abort. Specifically, we'll dive into those. These are all public X events for you to use. But how about the fact that you can go fire an X event when a plan is not cached, or somebody changes metadata, or when a spill happens to tempdb. So here's some pretty cool stuff that you can look at the deck yourself and go experiment with. One of them is parameter-sensitive plan optimization skip. That's a mouthful. That's a new feature we have in SQL 2022, right? That's really helpful to say, why didn't you guys go use that new feature? So you can turn on X event and see all these incredible reasons why maybe that didn't work for you. Or, you know, we have a team called the Ninja team at Microsoft that published a pretty cool blog about how to do some CDC troubleshooting with new X events. And quite frankly, to be honest with you, a lot of time these reasons showed up is because some developer said, I need to go debug something and I don't want to use a debugger. So I'll put an X event in the code to do that. And sometimes it was in the cloud and it showed up in SQL 2022. So let's talk about anti-patterns. Maybe you've had this scenario right here. Pretty simple scenario. Got a table, got a ID column, an varchar, put an index on it, you do a store procedure, oops, use an integer value. No problem, we convert that, but you don't get to use an index when that happens. This is what we call a typical anti-pattern query in the product. In fact, there's a bunch of them. And in some cases, what we decided to do was go fire an X event when we detect that query pattern in the code. So there are several examples where we do this. You can go look at this website, SQL anti-pattern, or you can see a demonstration of something pretty interesting like this, because one of the things that you want to see is when this happens, what was the query, and especially what was the plan? So let's see that in action. Let's do a recording and go through it. So I've got a database here in SQL 2022. Looks similar to what I showed in the diagram right there. I run the query, and I've got this X event established to fire called query anti-pattern. I see in the type that it's one of those ones I just shocked about, a conversion preventing an index seek. And I know the query text by looking here at the query text itself, but I want to see the plan. So I grab the plan handle live, run this DMV, get into the plan. I'll zoom in here in a second. And sure enough, I can tell that I got a query that's using a scan. And it's doing a conversion. If this happens in production, you don't know about it until somebody says the query's slow. And then you're like, why is this query slow? Then you go into Query Store and find out. If you had the query anti-pattern enabled in your environment, which is no performance degradation at all, no performance hit at all, you could try to go detect several of these patterns and go see, in this particular case, I had an integer value, the column was an nvarchar, whoops. And this could be a very common problem for administrators and people building tables and developers building stored procedures and not seeing each other eye to eye. And so what I did is I went in here and I altered quickly the procedure to make sure it's an nvarchar, went back again here and going to execute this. Let's kick it off. I'm going to go back now and see, is my query plan good now? So let's go back. We'll kind of kill off this session right here, but go back and run the query. And this time, instead of looking for the X event, I'll just go do what is the actual plan, run it, and sure enough, now I got my index seek. It seems like a pretty simple scenario. And I was thinking in my mind, is there a way for me to implement something like this in a DevOps pipeline? Next week, I can't believe this, I'm going from the UK to Vegas. I'm going to a developer event in Las Vegas, and I'm going to show, and I'll publish on the internet, a way to go detect this problem in a DevOps pipeline so you can detect it before it actually hits production. That would be kind of cool, right? If you go actually start using database projects, build DevOps pipelines, push through changes and test them to make sure these anti-patterns don't occur before they production. So that's an example, a very simple one of a query anti-pattern problem. And again, our developers put that in there because they were trying to debug problems with customers and see if these kind of things were going on. A good friend of mine, Microsoft, is named Robert Dorr or Bob Dorr. I call him the smarter Bob at Microsoft. We've almost been there the same time together in the company. He's one of those guys behind the scenes that's super smart, smarter than me. You ever seen the movie Big Bang Theory? He's Sheldon, I'm Penny. When we get together and have a conversation. In fact, he said, hey, Ward, he calls me Ward. He heard I was doing this. He said, hey, did you know about this thing, query abort? I'm like, what are you talking about? And on Teams, he was at his house, I was at my house, he whiteboarded this for me. It took me like an hour to understand what he was talking about. But it looked something like this. He wanted to know what was going on in the cloud when people would complain about queries failing, but there was no error. So consider this. When an app sends a query to SQL Server, it uses the TDS protocol to send over the query. A worker thread picks up the query. You may have seen this in scenario as a developer where you could cancel or do a query timeout, set that up on your query, and a timeout occurs. Now, if you ever wondered how we process that, we do something called an out-of-band packet or an attention packet. And what happens inside SQL Server is this worker thread is not capable of recognizing that packet because it's busy running the query or it's blocked on something. So a separate thing called an IO completion port, a worker thread, picks up this attention packet, and we know what session that belongs to. So what Bob did is he said, I'll tell you what, when I detect one of these attentions coming in, I'm going to fire a query abort event. Now, the reason he did that is this. There's an event called an attention event we've had forever. The problem is, you're going to see in a second, we only fire the attention event in the context of that query after it finishes the abort. So you have no idea what it was doing in between, and it requires a very complicated tracing process. So I've said, you know what, if I fire it right here, I can get the context of what that was doing. So he fires this abort event in the code, if you're listening in X event. We mark like a timer for an attention, and we mark the query aborted. We mark something in a data structure so that when this query is running, it can periodically check and say, hey, should I be aborted? If it's blocked, we can signal it through SQL OS to say, you should cancel. The query cancels, it rolls back a transaction, and after that actually happens, the abort, it fires that attention event. So if you only look at the attention event, you know those are happening, but you have no idea what this query was actually doing. Was it a cancel? Was it a query timeout? Or did an administrator kill that session? Now, it is true that a kill shows up in the error log, but wouldn't it be nice to know when you killed a session or when a cancel or a query timeout occurred, what was it doing? Was it running a long query? What was the input buffer? Was it blocked? And that's exactly what Bob was attempting to go after, using this concept called a query abort X event. So let's go see it in action. Again, let's do a demonstration. We can pause a little bit through this. So I'm going to run a query, this big cross join that I know takes forever. So I'm going to kick it off, and just basically in our management studio, I'm going to cancel it, but I've got X events set up to capture a query abort event. So there you go, and the attention event. So in the query abort event, we have a couple things that are very interesting. Now, we're going to geek out a little bit here for a second. Let me stop and pause this. So if you go look at this attention event, what you see is some things. This is the query abort event. You see, this is the actual session ID of the one running the query, and here's the query that actually had the abort. So that's the one that's currently running right now. Now here's what we're going to do. We're going to use call stacks. You didn't think we were going to use the debugger session that I did the other day in here. We are. We're going to call stacks. We're not going to use the Windows debugger, though, to do this. We're going to use a tool by my good friend Arvin to go look at call stacks. And you're like, Bob, I don't know what the call stack is. When I show you what this looks like, you will know. So this is going to be the call stack of the actual attention handler that picked up the abort. So if you go run this and you drill into this, you can see some things that I talked about. Listen IO completion port, that's a separate worker thread listening things out-of-band packets, and it's going to fire the abort event. And you're like, well, that's really exciting. That doesn't really tell me anything. What about the query? That's something called a T-SQL call stack. This is the actual execution call stack of that query running. Well, what's it doing? So I'll use Arvin's tool. By the way, you can see yourself in my demos how to do this. It's very simple to do to set up this tool. And I go in this call stack. Can you tell it's not blocked? It looks like it's running a bunch of things called hashes. This is a massive hash join thing going on. So probably what's going on is a query timeout occurred or somebody hit a button to cancel because this was taking forever. And that's one particular scenario. By the way, back into that X event right here, if I pause this, let me go back there real quick. Just winked a note here. Oh, come on, pause for me. Let me go back here. Pause right there. The session ID for the abort itself is 0. And you're like, wait a minute, why doesn't it have a session? Because that code listening on the IO completion port is not an actual session. It's just a background task picking up this attention packet. So you can know a lot of context of what's going on here. It's either a query timeout or a cancel for sure for this situation, because I'll show you in a second what a kill looks like. So let's move on from this. Sorry, let me go back up one here. So at the very end of this, I want to show you what the attention event looks like. Because I want to show to you the fact that attention event doesn't help you at all. It just shows you there's an attention. An attention could occur because of a cancel, a query timeout, or a kill. So in the attention event, notice here, it just shows you an attention occurred. Process messages is the code to just process a query, and attention means, well, we somehow just got aborted for no reason. That's what the old world used to look like. Let's look at what a blocking scenario looks like. So, same scenario, type of thing of an attention, except this time I'm just going to open a transaction, and I'm going to run another query that's going to use a query timeout, just 2 seconds, really fast, that's blocked. And I want to show you the same behavior of what this query abort looks like in a blocking situation. So, go to query abort again. This time, same session ID 0. Session ID is the query. Notice the select tab with hold lock. That's the query that's getting blocked, or the query timeout one. If I go in here and look at the T-SQL call stack and drill in, you'll see a distinct difference. Remember the other one showed like this big hash join thing? Notice the code. You see the word lock there, lock sleep? That is a typical call stack of a blocking query. So now, by looking at a query abort, guys like Robert Dorr can go, I can tell you exactly what's going on. There's a big blocking problem happening at this point, and a timeout is occurring, or somebody is just having a query timeout because of a long-running query. And we know the queries, so we can go back to the query store now and go figure out what's going on. A lot of great details. One last scenario. You want to do and see what's going with a kill. Again, a kill does show up in the error log, but you may be going after and going, I'm not even sure why I killed that. I just know this session's causing me problems. I just got to terminate this thing. So we can run this scenario again. I can go over and kill, in this case, session 51, look at my query abort again, and get information about it. Now, in this particular case, notice here the session ID called action. That's the session doing the kill. 51 is the one I'm killing. And here's the query. And then now let's go look what the call stack looks like for the query abort call stack. Not the one that we kill, but the one we did. So we can prove in here that we actually are doing a kill. You see right here? Nuke spid. You got to love that calls, right? Nuke spid. So that's what we do. Get rid of that thing, right? And then what does the T-SQL call stack look like? Well, I can tell as well, similar to what I had in the first scenario, it was a long-running query. I can pull this up and see now. In this particular case, I can paste it in and see it's similar to what I saw before. It's not blocked. Now, if it was blocking, I would see the same type of thing I saw before. In fact, it was in a blocking chain. So I've been able to now, just by using query abort and turning this on, and there's no performance penalty from turning this on. You can see scenarios and debug problems proactively about queries that are failing without errors. Cancel, query timeout, kill, blocking, long-running queries. Super cool technology. Bob told me that. I almost fell off my chair in my office when he showed me this. I was like, oh my gosh, why didn't you tell me about this? Oh, I'm telling you now. Well, Bob, go to SQL Bits and tell everybody. In the scalability space, we have some pretty cool stuff. We're going to show you hands-free tempdb in a second. I gave you a hint in the keynote. I was going to show you hands-free tempdb. Remember I said hidden gem, Aaron? We're going to drill in more to that perfmon graph I showed you. I want to first show you something pretty cool. Schema modification locks are painful because you do maintenance operations that go grab a schema modification lock and it blocks the world. And so what we've done is we've added a concept called low priority for some of these operations so they don't do that. They take a lower priority when they grab this lock. Let me show you an example. An offline create index grabs a schema modification lock in this scenario. Let's say a query's running. It's waiting now because this schema modification lock must wait for that query to finish. But guess what? Everybody lines up behind the create index. This is bad for the length of creating the index, which is why we created an online create index. Because a query could run, the index will start, and near the very end, it'll grab that lock. But even during that small portion of time, queries are blocked until it finishes finally its operation. Now, with this wait low priority, it looks something like this. Query's running, it comes in at the very last second, it needs that lock, but if you use that option, it goes into something called a low priority queue. And so what happens then is that a query comes up while it's in the status and says, oh, I get to go run. And when those queries finish, then the create index can come through and go forward. We've supported this now for shrink, for create index, for constraints, for async auto-update operations. So we're trying to make you more available when you're doing maintenance operations. A hidden gem, people saw that. It was on a bullet point in my slides. They're like, somebody came up to me at the conference and said, I saw that in your workshop again. What is that thing? This is what this is. This is helping you become more available by using low priority wait locks for schema modification. Okay, this is a fun part. When you're old like me, you get to tell stories. So I started in 1993, oh my gosh, diskettes. But there was this product that we did called SQL 7.0 in 1998. And in that product, we introduced the concept of latching. And I distinctly remember in product support, about 6 months after the product launched or so, we started getting calls at Microsoft support where customers said, I've got this, if you remember, sys processes. I would look at sys processes and I would see the wait type as being page latch and the resource said 2:1: something. And we're like, what? That's tempdb. And so we got all these things coming in. I called David Campbell at the time and the product team and I said, Dave, we're getting killed. We're getting this latch thing. He says, oh yeah, that's right. We put in this latch thing, by the way, in SQL 7.0. We kind of told you about it. We didn't think anybody really cared. Hello. I was like, Dave, we're getting killed by this. He goes, oh, I know your problem is you only got one file. I'm like, yeah, everybody's only got one file. Why is that a problem? He goes, well, as it turns out, in tempdb, everybody can get contention on these system pages for allocation. So with one file in, all these threads are coming in and getting this concurrency problem because latches are needed to protect the physical page. And I'm like, okay, what do we do? Oh, just create multiple files. How many? Well, and as you saw over the years, you've developed techniques to try to figure that out. I've given you some advice over the years. Start with 8, add by 4, et cetera. But that was a technique we did. We also added trace flags to make sure we use uniform extents, grow the tempdb files at the same level so that this whole file scheme would work. But this is not an I/O concept. This is not an I/O concept. This is not a page I/O latch. This is a page latch in memory of threads all hitting each other, trying to touch these system pages, and there is no latch hint in SQL Server. So you're like, okay, well, over the years we've added some stuff. Setups tried to help you a little bit. We tried to remove the need for the trace flags. And so what we found after doing some of these things is people would call us back and say, now I'm getting a page latch on 2:x: some page number that's not one of those. Well, we would go dbcc page, and it would be schobjs. And somebody would say, what the heck is that? I'm like, that's a system table. Well, as it turns out, we just uncovered a new hotspot. These threads are coming in and trying to do modifications against system tables as basis of your create drops that are happening all the time. And so the answer was, can you reduce your tempdb workload? Because there's no way around this. We introduced in SQL 19 tempdb metadata optimization, a server configuration option, to turn your system tables into memory optimized tables, which are latch free. We had a few issues when we launched 19 with that. Those have all been resolved. So if you turn this on, you can remove that hotspot altogether. What we also did is we got rid of the entire PFS problem, just got rid of it. We just totally changed the code so that even if you had smaller number of files, you just wouldn't hit that problem. So what happened was, when we launched this, we started doing more testing. We found we still had a few pages that had contention, even with multiple files. An Sch-M page and a GAM page. So what did we do in 2022? Latches are free, latches are, we just got rid of that. So now, with that option turned on, and using 2022, I will contend with you, but don't go do this at home. You can use one data file now, and you will not see latch contention. Let me show you. Okay. Wait, I got to show the fun little diagram. Does it do it? Wait, let me go back. Ah, that's funny. You too could be a PowerPoint expert. So here's an example where I took my system and I did one data file and one log file. Again, use best practices. I'm not suggesting go back in production and turn everything to one data file. So here we go, one data file, and I'm going to show you what this looks like, and I'm going to do 3 different tests. So in the first test, what I'm going to do is I'm going to not use tempdb metadata optimization, and I'm going to use trace flags to disable our new SCAM and GAM concurrency behavior in 2022. So only PFS optimization is turned on at this point. What does the behavior actually look like? That's test 1. Test 2 is turn on that new metadata thing, but don't use the 2022 stuff. And number 3 is just turn it all on and see what happens. This is what you saw in the keynote with these perfmon graphs. I'm going to show you behind the scenes kind of what it looks like. Okay, I'm using batch requests per second and page latch weights to measure things. Hey, quick tip, in my workshop on GitHub for free, you can try this yourself. So here I go. I love this. We added system functions to go figure out what objects belong to a latch. So I'm going to stress the fire out of tempdb. I'll turn off tempdb optimization. I'll disable the trace flags, restart SQL Server, and kick in this O-stress test I use to just hammer tempdb. Literally just, all I'm doing is just killing it. Bunch of crate drops over and over and over. And if I run this scenario, I'm going to observe performance. So let me go start perfmon. This is kind of what I was shortcutting in the keynote. Let me crank it up and see what happens. Now what you observe here, the green is the throughput. And the red is this crazy number of page latches. In fact, what does it get to? 100,000 per second or something like that. And if you run these system functions, you'll see it is these system tables causing the problem. So if you let this thing run, it finally finishes, but it's not great. The latches finally die, and you get an overall throughput performance. In fact, you can go measure, and it takes about 19 seconds. So let's mark that down in our fancy notebook, our fancy notepads recording here. So 19 seconds. We're being very sophisticated here using Notepad to record our measurements. Let's go do this. Let's turn on the metadata optimization to make these memory optimized tables, not your user tables, but the system tables. Let's just do that, but leave off the 2022 stuff and see what happens. And what I found, I didn't understand when I first saw it, but I'm explaining it. So turn back perfmon again, run the same exact tempdb workload and see what happens. Notice in here, the throughput's worse, but the latches are lower. Huh? That's because you get GAM latching, and it takes longer to acquire that latch than the system table stuff. So what's happening is there are less number of latches, but for longer durations. So I actually get worse throughput now by turning on the optimization we built in 19. It's like, what do you, now I'm only using one file in this case, by the way, but I still get a high number of latches, but I get worse throughput overall. That could be bad. So I go back, I'm just gonna pause perfmon for a second here just to make sure I can show all the measurements together. I get 28 seconds of performance. You're like, Bob, you're getting worse. I thought this was supposed to be an improvement. It's okay. With one data file, I'm gonna turn it all on. And the way I do that is I just restart SQL Server to get rid of these trace flags, to disable the optimizations, just restart the server, and let's go see what happens. And you saw in the keynote the beauty of this thing. So let me just kick it in, restart it, and do we get it? Do we get it? We'll run it, and like in the keynote with Aaron and I waving at each other, nothing. Zero latch. One data file, turn on tempdb optimization, restart SQL Server, zero latches, hammer tempdb with one data file. That is 25 years of innovation finally coming together. Yeah, so there's a clap in the audience. Thank you, developers. But you know what somebody said in my workshop? Under their breath, they said, finally. They weren't excited. They're like, finally you got rid of that thing. Do not go back and put in one data file in your production. Use best practices, but no, we are just trying to eliminate that pain from you altogether. It just took us a quarter century to do that. Okay, anyways, 12 seconds at the very end for that HammerDB, tempdb situation. That's a hidden gem. Doesn't make the press, right? So let's stop for a second before we move on and look for a question. There's a question?
Yeah, I think there's a problem with the application.
Okay, can you tell me what the question is?
Yeah. Wait at low priority sounds like something that should be enabled by default. Why isn't it?
Wait for lower priorities looks like something that should be on default. Why aren't you doing that? You know, we're pretty conservative at SQL Server when it comes to stuff like that. Maybe eventually we will make that a actual default. For now, we'll just take it on and make it a choice for you to decide. There are situations, by the way, maybe that you want to give the create index a priority. And therefore, that wouldn't be the right default decision. So that's possible we might do that in the future, but for now, it's an opt-in scenario. Is there another one?
Yeah. Is that abort XE stored in a ring buffer, or can it be redirected to a file?
Can the query abort X event be in a ring buffer redirected to a file? Here's the cool news. It can be, all X events can be redirected to buffers or files, and both. So you could turn on query abort and query anti-pattern, write it to an X event file, and let that just run in production, and then go analyze that offline.
Will metadata optimization cause problems with high tempdb usage in buffer form?
Yeah, question asked about will this new optimization cause problems with high tempdb usage? It is fair to say when 19 came out, there were some issues. We have fixed all those issues. So as the end of all the CUs for 19 and in 2022, we believe it's safe, but we're still conservative. We're not gonna make that the default in SQL Server. Okay, thank you, thanks for that. All right, let's do some other hidden gems. Let's keep rocking. Okay, just briefly to mention this because we have about 12 minutes left, I think. Is that about right? So if you use accelerated database recovery and you've had some issues, we've totally shored that up. Cleanup improvements, all sorts of great stuff. I feel very comfortable with people turning that on. If you've never seen cross-platform snapshot backup, I was actually talking to a customer yesterday. Let's say you're an Azure virtual machine and you're storing your databases in Azure storage, you by default now have the ability to do snapshot backups. And their scenario was, I love being able to just use an example from the conference. I talked to a customer. They wanted to take a massive 25 terabyte database from production and put it back in development. That's just gonna take forever and a lot of extra space. Use snapshots. You can actually take a T-SQL snapshot in Azure storage, even incrementally, look at this, in seconds. Pure Storage demonstrates this stuff in milliseconds. So you can actually suspend I/O, take a backup in seconds, but here's the key, restored in seconds. So take a look, we call it also T-SQL snapshot backups. So if your storage provider supports Snapshot, which Azure Storage does, this could be groundbreaking for you for like backup and restore Windows or dev test scenarios. By the way, quick tip, do not tell the support team I told you this. Oh gosh, this is recorded, isn't it? Darn. I used to work with those guys, that's okay. If you want to play with this on your laptop, go turn on trace flag 3661 and start the server. because we won't exclusively lock our files, and you can go copy them yourself and just kind of play with this technology. Okay, you promise not to tell anyone else about that. Okay, as we end up here a little bit, the last 11 minutes with all these fun hidden gems is, 20 minutes. See, I'm still thinking about the whole, 50-minute thing or something like that, right? So let me back up for a second then. Thank you. Thank you very much for reminding that. Let me back up here and show you this. Okay, cool. Because somebody asked me about this. They said, I don't understand why you can't just copy your files in SQL Server. So when SQL Server runs, let's say on your laptop, we exclusively open the files to ensure that other applications cannot touch the files, or else you would have a inconsistency of your files. If you open SQL Server and you can just bring up Notepad and start hacking away, you're going to just corrupt the database, right? So we do an exclusive open in Windows to do that. Well, storage providers at the disk level have no idea about that. So technically, you could go behind the scenes at your storage layer and try to go copy off these files while we're using them. That would also cause problems with those files that you're copying off. So we invented this concept called a snapshot. So the way this works is this, and it used to be through something called a VDI program that you would have to write, or you'd have to use the volume snapshot service and SQL writer program. So now you can go to T-SQL and say, suspend I/O for my database. This will freeze writes and reads to your database and log files. Then you perform your snapshot with your storage provider in Azure Storage. In the SQL Mechanics video I just released, I show you how to do it in Azure Storage. Could be incremental snapshot. Then you come back and you say, hey, back up the metadata, which resumes the I/O. This allows us to get a I/O consistent version of your files instead of having to stream the backup. And what I demonstrated in Mechanics was this. I backed up this database of 2.5 terabytes in like 17 seconds, and I restored it in the same speed. And somebody asked me, well, why would I want to go suspend I/O for 17 seconds on my workload? That's because restore is faster. Turns out, in hyperscale, that's what we do. So you rarely have to touch the actual files down at the actual layer of hyperscale because of that tiering layer about page servers and so forth. So we're comfortable behind the scenes doing snapshots for you because the files are in Azure Storage. And so when you do a point-in-time restore of hyperscale, we can easily just use a snapshot. We can recover a snapshot, recover the log for consistency, and we've been able to demonstrate 40 to 60 terabytes restores in minutes. That's insane. And so the power of Snapshot has been brought to you through T-SQL instead of having to write a VDI program. The key is you need to find a storage provider that supports snapshotting your files. Azure Storage happens to be one of those. Your laptop is not. Pure Storage is, though. Your major storage vendors that you work have all that technology. If you really want to know about this with the Pure folks, go to their booth. They have some really cool demonstrations. They're taking advantage now of this. And we called it cross-platform because guess what? It works now on Linux. Because of the fact that we're using the engine to do this, we support it on both Windows and Linux. At Microsoft, I work with some of the coolest people in the planet. And you see some of them here at this conference. Smart people, nice people, really, really, really genius. Bob Doerr is an example of somebody that you really don't even know. Occasionally you see Bob out there doing a blog or something, and maybe half the people get it. I told Bob one time he wrote a blog, I'm like, look, man, you got to rewrite this thing because even I don't understand it. But he just loves what he does. He's really good at what he does. There's another person named Purvi Shah, and I've known Purvi now for about 6-7 years. And when I first met her, I thought, man, one of the nicest. Slava Oaks introduced me to Purvi. He said, you need to go meet this person. She's just super nice, but she's so smart. I said, Purvi, I'm Bob Ward. Well, I know who you are. Well, what do you do at Microsoft? She goes, I make it faster. You do what? She goes, I just make SQL faster. And so, well, how do you do that? So she started explaining to me what she does, and I felt like the Sheldon Penny scenario, except she's super nice. And I'm like, okay, you got to translate this more for me. She's like, okay. So over the years, when I talk about a new SQL release, I always go to Purvi. During this, I said, what are you working on? Because I doubt it's making the press or a marketing slide or something. She goes, okay, well, in 2022, this is, I don't know, this is back maybe like last September before we made the release. She said, I'll work on it. I'll send you a summary of some stuff I'm doing. And the bullet list looked like this. And so I'm like, okay, buffer pool, promotions, I don't know what that is, but what it really is the ability for us not to overload a drive with the way we do I/O. So it's actually a more smoother I/O system for your system. It's just built in default in the server. We use spin locks on SQL Server for core concurrency of our threads, so that's super important. Thank you, Purvi, for doing that. We're just making the product faster. And then she just flew by saying, oh, by the way, I've kind of improved that whole VLF thing, and you can do instant finalization for the transaction log. I saw the last one, and I just fell off my chair at my home. I was like, wait, what? I called her. I was like, Purvi, you can't do that. We haven't been able to do this IFI thing for log files. That's not possible. She goes, oh, yeah, I figured that out. Can you explain that to me? She goes, well, as it turns out, what I discovered was when we auto-grow the log, I don't need as many VLS as I did before, so I can reduce that number. And I found out if I grow the log at 64 meg or less, the operating system presents zeros to us without zeroing the file. I'm like, yeah. So I said, so if we just do autogrow at 64 meg, even though I don't want to rely on autogrow, I'm good. She goes, yeah, and by the way, we changed the default to be 64 meg. Oh, great. So when I set up a new database, I'm set up for success if an autogrow actually occurs. I literally fell off my chair. I want to show you what this actually looks like. Okay, so I've got a database right here where I'm going to go this on purposely do autogrow. I'm going to pause for a second, make a smart statement here. We introduced autogrow a long time ago in a galaxy far, far away, partly because Bob Ward was really getting tired of getting paged, I'm dating myself, in the middle of the night because the database ran out of space. I remember specifically going back to the product team going, quit paging me at night because of 11:05. And they said, you know what, we could do this autogrow thing. I'm like, yeah, thank you. But it can cause issues for you, as you've seen over the years. So don't rely on autogrow, never do that. Try to size your databases correctly, size your logs correctly. But when it does happen, let's do this now to make it more manageable for you. So here's what I'm gonna do. I'm gonna introduce a grow scenario on purpose. So I'm gonna kick off a database. What I'm gonna do is create this database in this way. I'm gonna set up a database of 2 gig in data. I don't even wanna mess with autogrow for the data because I wanna use X events to show you what's going on. But I'm gonna create a small log and autogrow of 64 meg. And then I'm gonna introduce a simple workload with a bunch of inserts. And what I'm gonna do is I'm gonna track X event to see the behavior in the system without this improvement. So I'm using SQL 19 to do this. Got a large size row, easy to grow the log. You see what I'm tracking here? Let me pause this for a second. I'm tracking 2 X events, one called wait info external and one called database file size change. Wait info external is fired when we do what's called a preemptive wait type. In other words, when we call the operating system for an API call, we will track this in X event. And the name of the wait type represents the API call. So when we grow the log and we have to zero the file, we call write file gather, an actual Windows call to zero the file. Database file size change says, hey, if you change the size of the log file, record that X event. So in this case, autogrow is occurring, and they're both happening. So as an autogrow occurs for the log, I have to zero out the file, which on any kind of type disks is not good. It's still slowing you down, even on the fastest disk in the world. You're still getting, in this particular case, some 300 milliseconds of time to go do that. You can imagine for a slower drive, that's crazy. Used to be easier for me to show this in the days when I had spinning disks. But I'm showing a scenario where as I grow each part of the log, I'm spending cycles in the kernel zeroing out the log. I don't want to do that. I don't want to have to do that. We've had to do that in the past because we couldn't properly see the actual log correctly in what we call parity bits. We had to see it, we had to zero it to make sure we see everything correctly. Well, if the operating system now, when we do this, notice this took like 17 seconds. If the operating system now, when we grow 64 meg, if we don't have to zero it because it shows it as 0 with IFI, that would be really cool. Notice here that in preemptive wait types, I see a bunch of write file gathers. If you go in your system and see that happening, you're probably having a lot of these zeroed events occur, usually for autogrow scenarios. And I can see there are 51 virtual log files, which you've seen in the past potentially could cause you even issues during recovery or during restore. So I would like to be able to reduce the number of those. I'd like to be able to reduce and get rid of all those other scenarios. So let's go over to 2022 and let's just run the same thing. SQL 2022, I come in, I go in and create my database of 2 gig, my log of 8 meg, same type of scenario. Let's just run it again. Exact same script. By the way, all these demos are for you to run yourself too. You can just see them in action. It took 7 seconds this time, not 17. and I can see the differences by looking at X event alone. Notice there are no write file gatherers gone. I had the same X events set up to run, they're gone now. I just see the log changes. I just see the log grow operations happen each time, and I can go over and look at other pieces of data. Like let's go over and look at maybe like the weight types. I'm going through and looking at all the log file changes here. Come on, Bob, whoever did the recording here, let's go. Let's look at the weight types. Hello, hello. I must have been just droning on at home, just, to myself in my office going, this is beautiful. Okay, so look at the weight types here. They're gone. There's no write file. I don't have any of them. So that's just completely gone from my system. That's really helpful. And then how many VLFs I had? I have 51 VLFs? And I'm now down to 26, cut it in half. So I'm not suggesting, by the way, again, that you should always use autogrow, but by default in 2022, there are not just nice people, but super brilliant people like Purvi behind the scenes that know these problems because you've been there for a while and are just solving them. I just have to make sure that I call her once a week and say, what are you working on? So I can get the next hidden gem. But I just love being able to work at Microsoft with people like that. Okay. So let's stop and see if we have some questions here. Hey, it's showing up now on the monitor. Thank you. All right. I'm tired, man. I can't even speak. Do the storage snapshot backup utilize VSS? And can we then use redirected point-in-time restore? So you can still use VSS. All that stuff works. Not a problem. But we have a new way of doing snapshot backups that don't use VSS, and you wouldn't use point-in-time restore in those scenarios. You simply do a snapshot. I understand why you might want to do point-in-time restore, but you can't use it with snapshots. You're just literally taking a snapshot of the files at a point in time and bringing them back. Again, the key here is this. If you want to still use VSS, no problem. Still go do that. If you want to be free from having to use VSS and you have other scenarios where you don't want to do that, you don't have to do that anymore. You can just use the T-SQL commands, use your snapshot backup technology. Again, Azure Storage provides this by default, including incremental snapshots. That's what I show in the mechanics video. That's an option for you, but you cannot do point-in-time restore. So going forward from SQL 2022, we don't need to use more than one data file. What happens if we use? Great question. Going to make it clear because you're going to get on social media and say, Bob said use one data file for tempdb. Don't do that. I'm saying now, it's on record. What I'm saying is this, use your best practices. If it's 8, use 8, whatever it is. If you turn on tempdb metadata optimization on and use SQL 2022, we have poured all of our enhancements to get rid of latch contention in tempdb. Again, put it on a fast drive because you still have potential IO things to consider like spills or the writes to tempdb. But once you get rid of the IO thing, you've just got it on fast drives, use the tempdb meta optimization, use 2022, the problem goes away. I demonstrated it with one data file to show you what's possible, but please do not go back in production and say, let's just go back to one file. Now, can you go test with that? Sure. Go test with it and see what works in your system. I just showed you a demonstration that is possible to free the burden of the latch monsters from your tempdb. Okay, any other questions on there we see? No. Perfect, okay. All right, so one last topic as we finish today, and that is this. You saw me in the keynote with the Kingdom of Dell. That was hilarious, wasn't it? I didn't know they were going to do that, so that was pretty funny. I did work with Dell ahead of time to produce those keynote demos. So we have the ability now, you saw us in the keynote, I talked about this in the Wheel of Power a little bit, to go and take a table in SQL Server and archive it as Parquet files to cheap, inexpensive storage. Pretty cool. So what I decided to do was I said, I wonder if we could use partition switching to do the same thing. Because that's what a lot of times people are doing, right? You're creating partitions. You'll take a certain partition that is cold, and you'll switch it to, say, an archive table in SQL Server, and now that's your way of getting out of the main partition. Many people use that today. So I said to myself, well, if I do that, can I just take that archive table, use this concept called CETAS, create external table as select, run this against that table, and stick them over in Azure Storage or S3 Storage. In fact, what I could do is I could create this external table. I could actually create a folder within my Parquet, my storage system, call it, I don't know, 4th quarter of 2022, take the archive table that is that 4th quarter, archive it as Parquet, get rid of the archive table now out of SQL Server, and then go query any once in a while I need the cold data directly against that external table like a SQL table. That's pretty cool. And so you could create your own system to do cold archiving. I'm not saying it's StretchDB. We did deprecate that. I will tell you, though, that we're thinking about this. Can we go automate something like this for you to kind of make a stretch system now out of inexpensive storage? This is really powerful because now you can create up your partition switching system, and then typically that data is something you rarely access. And by the way, it's not that slow. Depending on a decent network speed, you can go access this data anytime you want. It's pretty fast. So it requires you, though, to have a fairly clever organization system for your folders within your storage system. So, and here's the beauty. It is in Parquet now. So you're using serverless for Synapse, you're using Databricks, Snowflake, whatever it is that can access Parquet files in a data lake, you have set up a data lake of archiving data from SQL Server. So now you can access it with any technology because it's just open source Parquet that we push up there to that environment. Way cool technology, another hidden gem for SQL Server. Okay, so pretty neat, right? Like this doesn't make the headlines. I really had fun putting this session together because it's quite frankly, it's stuff I discovered. I'm like, I don't think I knew that. We had that in the product. Some stuff I knew, I put it in the book, like query a board. I didn't even realize we had those kind of type things. I'll continue to do this. I was actually thinking, and I think the community would love this. I was thinking about now taking this and making a series out of it. And how about Azure SQL Hidden Gems? All sorts of stuff that we just don't have time to go beat the drum with large, big events and big talks and just things that the community does care about that makes their life easier. I want you to have resources. I want you to have your resources. And so again, at the top right up here, that's the deck, it's up there, and the demos are in the deck. But here's the Bob SQL demos. That's a GitHub repo. If you go look for a folder, it says like Hidden Gems. You can go in there and try the stuff yourself. All public information for you to try. And then here's the massive set of resources we have built for SQL Server 2022. Look at the workshop in the left-hand corner there. If you didn't come to the workshop here on Wednesday, I understand that. You couldn't do it. But how would you like to go do that on your own? You can. You can go on GitHub. We're open source presenters. You can take, and I'm telling you right now, I make a commitment to the community. You can take any of my materials, represent them anytime you want. I don't even care if you charge for it. Just present them. Just spread the good virus. I probably shouldn't say that anymore. Probably not a good thing to say. So let's see, one other question here. Should I increase SQL Server memory to use or provide for memory optimized tempdb? And the answer is no. The memory optimized that we use for tempdb in this case is very small. Because all we're doing is the metadata of tempdb, the system tables, not your tempdb tables. So you shouldn't have to concern yourself. Some of the problems that we had, though, did cause that issue, but we have resolved and fixed those issues in the latest CE for 19 and in SQL 2022. Guys, again, it's such a privilege to be at this event. Please go make sure you tell thank you to any of the volunteers that are here. I will go right after here. I'm going to pack up and go to the booth to sign more books. I'd love to meet you in person. And thank you again for attending SQL Bits.